This is problem 12 from chapter 20 of Giancoli. In this problem, it's a little bit different from giving a velocity and a magnetic field. In this case, we are given a velocity and a force, and we're supposed to infer what the direction of the magnetic field is. You point your hand in the direction of the velocity. The force is going to be the direction your thumb points, and your fingers will curl in the direction of the magnetic field. I tried to draw it here in 3 dimensions for you. So these are all perpendicular to one another. The yellow's kind of pointing toward us, the force, and the velocity's off to this side. The magnetic field is up in this case. And this is the relationship that there will always be for positively charged particles, and the game is just to rotate this until we can find out which way the green arrow is pointed. So in this case, if our hands are pointed toward the left, we rotate our hands until our thumb points in the direction of force, because that would be the resultant of the way we normally do it. Our fingers can only curl down in this situation, and so the magnetic field points down. Here in part B, now our hand points toward the left, toward the right. We rotate our hand until our thumb points in the direction of the force. Our fingers can only curl into the screen. And so the magnetic field is into the board here. It must be. For this part C, now we point our hand toward the screen, point your arm into the screen, rotate your hand until your thumb points in the direction of force, and now our fingers can only curl to the right. You can check to see, but all of these are just this same pattern, rotated different ways. The problem we did in the homework had the magnetic field and the speed given, and it was also a negative particle, which throws another curve. For a negative particle, the force is just away from you, but it's the same situation. It's always the same setup, and you just rotate it in space. This is why we can use the right-hand rule.